Hey everyone, welcome back. So today we're going to be solving count primes. Uh, I've not solved this question yet. I'm going to be solving it with you. Yes, I did attempt, but I ended up getting a TLE, I believe. So I'm going to be solving it with you. And I figured out the approach. It's a very, very, very interesting problem. And I'm going to be going through the solution from beginning. So for the people who don't know, who have not solved this or who are stuck at like let's say TLE or the place where I got stuck, you'll be able to figure out where you got stuck and how to think, right? And that's exactly what we're going to be doing over here. Okay, so let's get started. The question description is very simple. It just says that from 1 to n you need to print out all the numbers which are prime, right? So if you take n equals to 10, you need to print out all the numbers which are prime. Like for example, all the numbers which are prime from 1 to 10 are 2 3 5 7, right? 2 3 5 7, right? Now so what we'll be doing is ideally, uh, you know if when we think about it visually, we'll just say that okay, how do you find out prime numbers from 1 2 to 10? You just go to a number, let's say 5. You check if 5 is prime or not, right? Okay, it's not a prime, so I can take 5. It is a prime, so I can take 5. Okay, then I'll go to 7. Okay, then you think about it, is 7 a prime number or not? Yes, it's a prime number, you'll take 7. That's how you do it visually. And that is exactly how a brute force way also would ideally work. Okay, let's look into it. Now n is given as 10, right? Now ideally we need to figure out the number of prime numbers from 1 to 10, right? What is a prime number? Can I say that a prime number is something, okay, a prime number is something two which has two factors? Exactly. Exactly is the keyword over here. It has two factors exactly. What does two factors exactly mean? If we take 5, how many numbers are divisible by how many numbers are divisible by 5? As in, how many numbers, if we do mod 5 is x, I get 0. How many numbers are there where mod 5, that number will give me 0, right? It's nothing but 1 and 5. Do you see any number? No. So this has exactly two factors, right? So I can say 5 is a prime number. Similarly, for others, it's the same thing. 1 is not a prime number because it's neither prime nor composite, so we're gonna not gonna consider that. We're gonna only consider from 2. Okay. Now you can be like, hey Siddharth, this problem is very simple, right? What I'll do is I'll just take my value from 2 to 10. Okay. Okay. I will say okay 2 for, let's say, let's take a number in between, right? Let's take n is 4. What I'm saying is, for n is 4, what I'm saying is I'll see if 4 is a factor or not. First task is to go from 2 to 10, and I need to see if 4 is a factor. Like, let's say a number is factor or not. Okay. For to find 4 is a factor, what will I do? I'll go from 1 to 4. I'm talking about a brute force way. I'll go from 1 to 4. Okay. Okay. If I go from 1 to 4, I'll go from 1 to 4. Right? Perfect. I'll find it out. Then I'll pick up n equals to 5. For 5 also, I'll go from 1 to 5. For n is 6 also, I'll go from 1 to 6. So if you think about it, your initial loop, that is your initial loop, first loop, is running from for I equals to 2 to n, right? The second loop is running from for I equals to 1 to a of I. So it is a nested loop. So just think about it. You have n numbers, okay? Look at the constraint over here. You have 10 past 6 numbers. For 10 past 6 numbers, you're running from 1 to 10 past 6. Okay? You're running from 1 to 10 past 6. And for each, let's consider the 10 past 6 the number, right? For 10 past 6, you'll be going from 1 to 10 past 6 again. So do you get how complicated it is? Like, you're going from 1 to 10 past 6, that is 10 past 6. And then here also you're going from 1 to 10 past 6 into 10 past 6. This will give me 1 into 10 past 12. Do you see how big of a number this is? Right? So your time complexity will be O of n square, right? It'll be ideally n into yeah, n square, right? N square, when you generalize it, right? It'll be O of n square. So do you see how big this is, right? So 10 power 12, think about it. 10 power 6 into 10 power 6, 10 power 12. Obviously, at least your processors which process these online editors, it's not going to process more than 10 power 8. Obviously, we'll get a TLE. So now you know that, okay, brute force approach is easy, but it's not going to work, right? Now let's try to optimize it a bit. Okay, let's do one thing. The initial for loop, let's keep it the same. That is the first for loop. What I'm saying is the first for loop will ideally go from for I equals to 1 or I equals to 2 to n. Okay, but your second for loop, what I'm doing is I'll try to optimize the second for loop. So try to optimize second for loop. Uh, the second for loop. Okay. So what I'll do is I'll pull it over here. The second for loop, what I'll do, see, the second for loop, if you think about it, if n is 100, initially what we were doing is we were running from 1 to 100. So 100 iterations were happening, right? But just think about it. Do I really need to go to 100 to find all the prime numbers? Can I not find all the... Okay, wait. I made a mistake here. From 1 to 100, I'm not finding the prime numbers. From 1 to 100, I'm finding the factors of 1 to 100. Number of elements which are divisible by 100. I'm finding the factors from 1 to 100. I'm not finding the prime numbers, right? If n is 100, to check if 100 is a prime number or not, what is a prime number? It should have exactly two factors, 1 and 2. So I'm checking how many factors are there for 100. If the factor is 2, then I'm going to say 100 is a prime number. Okay. So what I'm going to do here is I need to run from 1 to 100, right? Do I really need to run from 1 to 100, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15, 100 till 100? Do I have to do that? Just think about it, right? I don't have to, right? There's a better approach. What is that approach? Can I say that I'll go from I to square root of 100 or I square, I cross I? Let's think about it, right? What is 10? What is 10 cross 10? It's 100. Okay. What is 11 cross 11? It's 121. Okay. So what I'm telling you is that I will go from 1 to 10 cross 10. I'm only talking about example 100. We'll generalize it later. I'm going from 10 cross 1 to 10 cross 10, right? As in like 1 cross 1, 2 cross 2 till 10 cross 10. And after this, I'm going to break, right? Let's see. Let's see if I go from 1 to I cross I less than or equal to 100. If I'll be able to find out all the elements or not. Okay. When I is 1, I equals to 1. Okay. 1 cross 1. So I is 1, right? I is 1. I'm checking if 1 is a prime number or not. I'm checking if 1 is a factor of 10 or not. Yes, it is. Why? Because for I is 1, let me write it like this. For I is 1, 100 divided by 1, mod by 1 will give me 0. Okay. So I'll have 0. So I have factors. Factors is 1. Okay. Now I'll go to 2. I'll check if 2 cross 2 is less than 100. Yes. Right. So I'll check if 100 percentage 2 is equal to 0. Okay. Perfect. If 100 percentage 2 equals to 0, what will I do? What will I do? 100 percentage 2 equals to 0. Okay. I will increase my, I'll add 2 to my factor list. Now I equals to 3. No, this is not. So this is going to not equal to 0. Okay. I equals to 4. 100 percentage 4 is equal to 0, which is 20, like 100 by 4 is 25, right? Okay, okay. Now I'll add 4. Okay, now I equals to 5. 100 percentage 5 is equal to 0. Okay, I'll add 5. Okay, now 6 is not, 7 is not, 8 is not, 9 is not, 10. Now 10, I equals to 10. 100 percentage 10, yes, it is 0. Okay, now I've gotten this factors 1, 4, 5. Are these the factors of 100? No, right. 100 has so many other factors. If we calculate manually, you get 1, 2, 4, 5. Okay, I'll need to add 10 also, right? I'll add 10 also, right? You get so many factors: 1, 2, 4, 5, 10, 20, right? 25, right? 50, right? And 100. You get so many factors. These are the number of factors that is that is under 10, 100, right? Now, but I've calculated only, but I could find out only 1, 2, 4, 5, 10. Now you can ask me, hey Siddharth, how is this correct? You are saying that go only till I cross I is less than equal to 100. Now if I do that, I'm only getting these values, right? How is that correct? Okay. Now let's do one thing. Let's do the same thing again, right? For 100, right? For 100, what I'm going to do is I'm going to go from I equals to 1 to I cross I less than or equal to 100. This is my range. I equals to 1. I equals to 1. 100 percentage 1 is 0. Okay. If 100 percentage 1 is 0, perfect. What is 100 by 1? 100. Now tell me something. Can I say that if 100 percentage 1 is 0, 1 is a factor? If 100 percentage 100 mod 1 is 0, 1 is a factor. What is mod? It's gonna give you the remainder, right? It's 0. Perfect. 100 by 1 is gonna give me 100 because it gives you the integer value, division value, 100. Can I say that both 1 and 100 are factors of 100? See, if mod something is going to give me 0, by something is going to give me a whole value. Okay, that whole value is also a factor of 100. Yes, of course, right? If you see mod 1 is giving me 0, by 1 is giving me 100. So obviously 100 will also be a factor of 100, 1 will also be a factor of 100, right? So let me store it to my answer. 1 and 100. Let me go to I equals to 2. Percentage 2 is 0. Perfect. 2 is a factor. By 2 is 50. Can I say that 50 is also a factor? Yes. So what I'm going to do? 2, I'm going to take 50. Okay. I is 3 is not valid. 4 is 4. I'll come to 4. 100 percentage 4 is 0. 100 by 4 is 25. 25 is also a factor. Yes. I'm going to take it 25. Right? Or wait. Yeah. Okay. Now I equals to 5. 100 percentage 5 is 0. 100 by 5 is what? 20. Right? So I'll include both 5 and 20. Okay. Now 6. 100 percentage 6 is not valid. Let me not write that. 7 is not valid. 8 is not. 110. Okay. Now I'm okay. Now you can have, this is a very important point. 0. 100 by 10 is 10. 100 by 10 is 10. Okay. Now tell me something. Okay, I'm going to include percentage 0. Okay. Now tell me something. According to whatever we've done, what would be our answer? Our answer would be 10 and 10. Okay. If it's 10 and 10, should I include both of them? No. So I can have a condition that if 100 percentage the value like a of I would be equal to 0, would be equal to 0. Okay, then what I'll do is I'll check another condition. If if 100 by that value equals to that value, 100 by 10 is 10. What I'll do, I'll only increase it by 1. Here what I'm doing, for every value I'm considering 100, 250, 425, 520. I'm considering two values. Now that it's the same thing, I don't have to consider two values, I'll consider only one value. Plus equals to 1. Else what I'm going to do, I plus equals to 2. Perfect. Perfect. This would be our logic. This would be the entire logic. This would be our entire logic for this particular algorithm. Right. Now, tell me something. What is the time complexity now? Initially, the first loop, this loop, will be running n times. Right. This optimization we have done, till where will it be running? If it's 100, it'll be running till 10. If it's 16, it'll be running till 4, right? If it's 30, it'll be running till what? If it's 30 is not a a number where you can get a definite power. So till 30, where 30 will run till what, 5, right? Because 6 square is 36, right? So do you see how much optimization we have done? Initially it was running from 1 to 100. Now it's running only from 1 to 10. Do you see this optimization that happened here? Right. So where would our algorithm, where would our iterator run till, right? It will run till nothing but root of n. Root of n. So I can say my time complexity is, for this one time complexity is n, for this one time complexity is square root of n. Perfect. So from n square we brought it down till n into square root of n. Perfect. This is our first approach. This is our second approach. Perfect. Now think about it. Will this still work? If your input constraint is so harsh, like if it's so much, will it still work? No, it's still throw an error. Square root of 10 power 6 into 10 power 6 will also exceed your this thing, right? Okay, so now there is a way to optimize it. Let's see how we can optimize it. Okay, now let me do one thing. Let me take n value to be a little higher value. Let's say n is 15. Okay, let me write all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or let me take this 20 hours. 20, 16, 17, 18, 19 and 20. Okay. Now I need to find out all the numbers. So the question says, let me change it to 20. Question is, find all the numbers from 1 to 20, right? This is our final optimization. Let's see how to do it. Okay. Now, what I'm going to do, I'm going to see, okay, is 1 a prime number? Okay, let me start from 2 actually, right? Forget 1. Let me start from 2. I'm going to see, is 2 a prime number? Is 2 a prime number? Okay, okay, before we do that, what I'm going to do is, I'm going to have an array from which is going to hold Boolean values, right? Once again, which is going to hold the Boolean values. I would need a bigger array, I feel. Okay, let me have this array which is going to hold Boolean values. Actually, let me cut it down to 15 itself, right? Okay, okay. When you create an array of size, let's say 20, you need to have Boolean values, right? Okay, perfect. Now what I'm going to do is, in that Boolean array, what I'm going to do is, I'm going to set every the length, that is 15, from like length of the array is length is 15, right? I'm gonna set the entire thing to true. Okay, I'm gonna set the entire thing to true. I'm not gonna write it over here because it doesn't make sense. It will be very big. Okay, I'm gonna set the entire thing to true, meaning that I'm gonna assume all the numbers are prime, right? So ideally, all of them were true, right? If you see all of them, they are prime numbers. Okay, now, okay, let me actually mark it like this. All of them are prime numbers. Okay, now what I'm going to do is I'm going to change it via some operation. Let's see what that operation is. Ideally, I'm assuming all of them are prime numbers. So what I'll do is I'll create an array of size 15. I'll set all of them to true. So this, let me call it is prime. Okay, now what will I do? Okay, let's think about it. Now I'll check 2, right? Is 2 is 2 a prime number? How can we check it? Again, that we found out the time complexity of that is square root of n, right? We're going to use the same method. I'm going to check if 2 is a prime number. Okay, 2 is a prime number. Okay, now tell me something. Until 15, if 2 is a prime number, the multiples of 2 until 15, will those numbers be a prime number or not? So multiples of 2 until 15 are what? 2, 4, 6, 8, 10, 12. Are these numbers, if this is a prime number, right? If these are prime numbers, the multiples of 2 until 15, this 14 also, 14, until 15, are these prime numbers? No, because I know for a fact they definitely have a factor of 3, factor of 1 extra. By 1 extra, what I mean is by default they have a factor of 1 and 4, right? Every number have a factor of 1 and itself, right? N and n, right? 1 and n, right? So I know for a fact by default for n there are 2 factors, right? It is a prime number if there's only one factor. Well, sorry, it's a prime number if it has only 2 factors. If it has more than 2 factors, it's not a prime number, right? I know that. By default, it has 2 factors, right? By default, every number has 2 factors to it. Now tell me something. The multiples of 2 until 15, like 4, 6, 8, 10, 12, 14, are these prime numbers? No, because for each number, there's one more additional factor, which is 2, right? Right? So 2, 4, I can take it as 1, 4, and 2, because 2 is also a factor of 4. Perfect. For 6, what is it? Same thing. 1, 6, 2. For 8, what is it? 1, 8, 2. For 10, what is it? 1, 8, 10, 2. So there's one additional factor, right? Which will defy our prime number definition. So we can say these are not prime numbers. That's exactly what I'm going to be doing here. So what I'll do is, for all the multiples of 2 until 15, I'm going to mark it as false, meaning that those are not prime. So what I'll do is I'll mark 4. I'll mark 6, I'll mark 8, I'll mark 10, I'll mark 12, I'll mark 14, 10. So what I'll do is I'll mark 4, 6, 8, 10, 12, 14. So ideally, what is green? Green is, so that you don't get confused, not prime. Whereas your red is prime. Okay, perfect. Okay, now I'll go to 3. I'll see if a 3 is marked as false. No, it's not marked as false, which means that I'm assuming that it's a prime number, right? Is 3 a prime number? Yes, 3 is a prime number, right? Okay. Now let's find out the factors of 3 until 15. What are the factors of 3? Leaving 3. 3 until 15, right? So what I'll do is factors of 3, multiples of 3 until 15, right? Okay, that is nothing but 6, 9, 12, 15. These are the multiples. So I know for a fact for every number in this particular range, this every number in this particular range, that is 6, 9, 12, 15, I know for a fact these are not prime numbers because they have one additional factor. They can have any other factor, but I know for a fact it can have one additional factor than the two default factors, which is nothing but 3. So 9 will have 1, 9, and I know for a fact it'll have 3 because 9 is a multiple of 3, right? 3 is a factor of 9, correct? So what I'm going to do is I'm going to remove all these. 6 is already true, so I'm not going to touch that. 9 I'm going to remove, then 12 is already done, and then 15 I'm going to remove. So what I'm going to do, I'm going to set 9, 15. Perfect, done. Okay, now it's done. Did I miss any? No, yeah, I didn't miss any number. Okay, now I'll go to 5. Okay, I'll check if 5 is a factor of 5 is a fact. Okay, wait, I made a mistake. I should not be starting with 1, right? Because 1 is neither prime nor composite. I'll start from 2 itself. Okay, now 5. Okay, 5, what will I say? Is 5 a prime number? Yes, 5 is a prime number. Let me find the factors of 5 until 15. 5, what are the factors of 5? 10, 15. These are the factors of 5, right? So these are not prime, so I need to mark these. So what I'll do is I will simply go here, mark them. That is 10 is already marked, 15 is already marked, done. Okay, now I'll go to 6 is marked, I'll go to 7. What are the factors of 7? 7 is nothing but 14 and 15. 14 and 21, right? So I'll consider only 14. So these are the factors, these are the multiples of 7, not factors. I keep saying factors, but these are the multiples of 7. So what I'll do is this is not marked, so I'll have to mark it. I'm going to mark it. Perfect. Now done. Now I'll come to 11. 11. Okay. 11 is 22. Right? It starts from 22. 12. It starts from 24. 13. 26. 14. 28. 15. 30. Okay. Perfect. Now tell me something. The numbers that I have not marked, 2, 3, 5, 7, 11, 13. Can I say that this is the count of number of prime numbers till 20? Yes, let's find it out manually. What's the prime number till 20? 2, 3, 5, 7, 11, 13, 14, 15, 16, 17. 17 is also 1. Oh, I mean, sorry, I'm considering n only till 15, right? Yeah. Till 15, what is it? Till 14, 13, wait, 15, right? Yeah, till 13 will go, and then 14 is not a prime, 15 is not a prime. Okay, so when I did manually, these are the prime number. Are these matching with 1, 2, 3, 5, 7, 11, 13? Yes, they are. So what is the count? 1, 2, 3, 4, 5. So count is 5. Perfect. Perfect. Right? So this would be our approach. Okay, there's one more little optimization in this approach. Let's see what it is. When I came to 11, okay, I know that 11, what are the multiples of 11? It is 22, and it'll keep on going. 33 will keep on going. I know for a fact the first multiple of 11 is going to exceed 15, right? So I know for a fact whatever number is after 11, that is 12, 13, 14, 15, is definitely the multiples of them are also going to exceed 15. I know that. So can I say something like, when the multiple of a given number, like any I into multiple of that number, like 2, if it's greater than my n, that is 15, I don't need to check it out. I'll just break, right? Because I know for a fact this number is multiple of this number, that is 2, which is 22, which is greater than 15. So I'm never going to, I don't have to check anything, right? Because I only have to find the prime numbers till 15. So I can say that 11 into 2 which is 22, is giving me a number greater than 15. So I'll break at this point. This will be my breaking point. No, not this will be my breaking point. This will be my breaking point. This will be my breaking point. Right? This will be my breaking point. Then I'll stop. Then I'll return whatever answer is there. Right? I'll return whatever answer is there. Perfect. Now that we know the optimized approach, let's try to code it. Okay. Now, let's see how to code it actually. Okay. Should I create an array where I need to put elements from 1 to 50? And then, yeah, so I'll be creating an array of size 16, I believe. Okay. So, what I'm going to do, like I told you, I'm going to have a boolean array. So I'm going to be calling boolean of I'm going to be calling it is prime equals to new boolean and what is the size of it. So you need to find out numbers from 1 to 10, right? 1 to 10, right? Will 10 be included? No. If you see over here, it says that strictly lesser than n, right? So if it's 7, you'll say that the output is 135, not 7. So what I'll do is that's good enough. So I'll create a of length n, right? Perfect. So I'll also be creating a function to check if it's prime or not, right? So I'll call it public. This will return a boolean value. I'm gonna call it is prime check of, it'll take a value in 10, or yeah, it'll take a value of in 10, or I call it int val. Okay. Now here it's very simple. So I'm gonna have a count, right? And then what I'm gonna do is I'm gonna iterate from I just like we discussed, go to square root, right? We figure out optimize the second loop from n to square root of n, right? So it's gonna start from 1, and then I cross I is less than n, less than or equal to my val, right? And then I plus plus. Either I can say square root, I mean x equals to square root of y, so x cross x equals to y, right? So that's exactly what I'm doing. Right. Now if I mod no, if val mod I equals to 0, so I need to check if val by I val by I equals to I, right? If it's equals to I, what I'm gonna do is it's very simple, right? I'm gonna say count plus equals to 1, right? Else count plus equals to 2, right? Perfect. Now what I'm gonna do is if so what it's gonna do is I'm gonna return if my count is less than count is return true if my count is less than okay, not less than, equal to 2. If my count is equal to 2, it's going to return true, else it's going to return false. Okay. Now what I'm going to be doing here is I have is prime, right? I've created this thing. So what do I need to do? I have 0 and 1 also, right? I'm going to set is prime of I don't want 0 and 1, right? Obviously. So 0 I'm going to set it to false. Is prime of 1 I'm going to set it false. Okay. But the thing with Java is when you create a boolean, all the default values are true, right? So I'll use inbuilt method arrays.fill is prime array to true. So I want to set all the values to true, right? So now what will I do? I'll simply go from int I equals to 2, right? I told you that it'll be going till n by 2, right? Or I cross 2 equals to uh, is less than n, and then I'm going to say I plus plus. Okay, perfect. Now what I'm going to do is I'm going to go for j. I'm going to check if is prime of that number, checking is prime of I, if it's true, meaning that it's this thing, and check is prime of is prime check, right? Sorry, is prime check of I turns out to be true. What I'm gonna do, I'm gonna get it. So here what I'm gonna do is I'm gonna have j, and where does j start from? Think about it. It will start from, we have to optimize it a bit, we'll do that, but where will j start from? Think about it. j will start from where? I cross 2. That's what we've done, right? For 2, where did it start from? 4, then 6, then 8, then 10, like that will keep on going. J is less than or less than n, and then j plus equals to I, right? What I'm going to be doing, I'm just going to be setting is prime of j equals to false. I'm going to be setting these as false. Perfect. Done. Now our work is done. Here what I'm going to be doing is I'm going to be iterating through the entire array again. Okay, I'm going to have something called as int final count equals to 0, right? This would be our final count, right? I'm going to say boolean val of is prime, and then what I'm going to do is if val final count plus equals to 1, and then what I'll do is return final count. I make this mistake always. Yeah, return final count. I'll make this in camel casing. Perfect. Okay. Now let's actually run the default cases. Okay. Now n equals 10, right? What is n is 0? We need to handle that because this will throw a out of bound exception. So what I'm going to do is I'm going to handle it for both 0 and 1. If n equals to 0 or n equals to 1, what I'm going to do is return 0. Okay, let's run it. Perfect. It looks good. Let's run it. Okay, I got it. Okay, my bad. Okay, I didn't initialize that, right? Okay, perfect. It accepted. Let's submit it. I'm saying that I'll throw a TLE. Yes, I throw a TLE. Okay, you'll be like, hey Siddharth, we optimized it so much. How is it still throwing a TLE? That's a good question. Okay, now let's see. Okay, let's look at it. Right? Let's take a number. Right? Let's take a number. 5. No, actually, let's take the same number. N equals to 15. So what I'll be doing, I'm going from 2. Currently what I'm doing is I'm going from 2. So what I'm doing is 2 into 2, 2 into 3, 2 into 4, 2 into 5, and so on till I reach I by n, I equals to n by 2. Sorry, yeah, I equals to n by 2, right? I is less than n by 2. Perfect. Now for 3, what will I do? I'll go 3 into 2, and then I'll go 3 into 3, I'll go 3 into 4, I'll go 3 into 5. Okay, see. For 4, what will I do? 4 into 2, and then 4 into 3, 4 into 4, and then 4 into 5. Okay, 5, what will I do? 5 into 2, 5 into 3, 5 into 4, 5 into 5 into 5, and then 5 into 6. Let us see. Do we observe any pattern over here or any repetitive work? What is the whole idea about optimizing a solution? It's about reducing the number of repetitive work that you're doing. That is how whole dynamic programming or recursion, everything came up, right? Right. So our task is to reduce recursive work, reduce the repetitive work. Okay. So let's see. 2 into 2 I'm having. Okay. 2 into 3 I'm having over here. Wait. 2 into 3 I'm having over here. Oh, just 2. 2 into 3 I'm having over here. Okay. Hey, just one second. Let me increase it a bit. Okay. 2 into 3 I'm having over here. Okay. Okay. I see 3 into 2 also over here. A into B is B into A, right? Yeah. Okay. 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 For 3, I'm having 3 into 3 over here. Okay. I'm seeing 3 into 4 over here. Again, 3 into 4 over here. Okay. I'm seeing 2 into 4 over here. I'm seeing 4 into 2 over here. Okay. I'm seeing. Okay. Okay. Now I'm seeing 2 into 5 over here. I'm seeing 5 into 2 over here. Right? Right? I'm seeing 3 into 5 over here. 5 into 3 over here. I'm seeing 4 into 5 over here. 5 into 4 over here. Okay. So all this, for example, if you take it for 5, all this value has already been pre-computed by either 2 or by 3 or by 4. 5 into 2 was computed by 2, 5 into 3 was computed by 3, 5 into 4 is computed by 4 already. Your new computation starts from 5 into 5. Similarly, for 3, no, let me not mark it like this. It'll look like, okay, right. If you see 3, let me not mark it over here. Let me mark it for the, yeah, yeah, 3 into 2. If you see, yeah, now it's better, right? If you see for 3 into 2 has already been computed. You're starting from 3 into 3. For 4 also, you're starting from 4 into 4 because 4 into 2, 4 into 3 has already been computed. Okay. Now, can I say that instead of starting from I cross 2, I can start from I cross I? Perfect. Okay. So perfect. I'm going to change that. So what I'm going to do here is simple. Here what I'm going to do is starting from 2. My bad. I equals to 2, not I equals to 2. Yeah, I equals to 2. Instead of starting from this, I'm going to convert it to I cross I. Okay. Okay. I'm going to be starting from I equals to I cross. No. Sorry. Yeah, I is 2 itself. I is 2 itself, right? I'm going to be starting J. Initially, it's starting from. Initially, it was being started from I cross 2, right? And I'm going to be starting from I cross I, right? I'm going to be changing it to I cross I. Perfect. Now that we've changed this, okay, let's run it. We'll get an automon exception. If I try to submit it, you'll see that I'll get an out of bound exception, right? Why? Because when your n value is this much, right, what you're trying to do is you're trying to store s prime, okay, that is in this array, s prime array. You're trying to store uh, a value which exceeds the given length, because of your n cross 2 should, like, you're ideally going till the elements where you're starting from the elements with I cross I, and you're going till n. You're going till n, right? So it's trying to store a a very huge value, that a value is greater than the length of the array, right? So what would we do? Okay, let's think about it. Let's come back to this. So for 15, this is what we had: 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now let's apply the same thing. Okay, now all these I'll mark it with red. Okay, by the same thing. Okay, now tell me something. For 1, what am I checking? I'm checking if 1 cross 1 here. What am I checking? I'm checking if 1 cross 1 is less than or equal to n. Yes, of course it is. Okay, of course it is. Right? So I'm gonna leave that. Okay, actually, ideally, I'll be making this one as green, right? Yeah. No, I mean, sorry. Okay, perfect. Now, 2. For 2 is a prime number, and this is currently true, right? So what I'll be doing, I'll be checking 2, 4, 6, 8, right? Okay, I will start from I cross I, right? That will be 2 cross 2, so it will start from 4. Okay, so 4, it'll make it it'll make it green. Let me mark it like this itself and make it green. 5 will make 6 will make it green. It's going till end, right? And then 8, 10, 12, 14, it's making it green. Perfect. Okay, now then what will come to 3? Okay, I'm checking 3 cross 3. If it's 3 cross 3, yes, 9 is less than 15. Okay, then I'm going to do the same thing for 9. So I'm going to set 9, 12 is already set, and then 15. Okay, then I'm going to 4. Okay, for 4, it's already set, so I'm going to ignore it because it's already green. 5, I'm going to go. 5 cross 5 is 25. 5 cross 5 is 25, and 25 is not less than n, right? 25 is not less than n. Okay, 25 is not less than n. So do I have to compute anything? If it's not less than n, 5 cross 5 is not less than n, do I have to complete anything? Can I just say that this will be my new breaking point? Initially, what was a breaking point? I cross 2 was a breaking point. So I was setting I equals to n by 2, or I cross 2 equals less than n, less than n, less than n. Now, while this was happening, while j was being started from I cross 2. Now j is being started from I cross I. So what will be my range until I will go? I should go till I cross I less than, no wait, I should go till from 2 till I cross I less than n, right? Do you see this? This is less than, okay, I ideally stop at 3 itself, right? But if you see 5 cross 5 is 25, and this will be my breaking point because I cross I does not exist, right? When we're doing j equals to I into 2, I was setting my I to go from 2 till I cross 2 is less than n. Okay, similarly, when j is going to I cross I, my I will go from 2 to I cross I, which is less than n. Okay, so what I'm gonna do, I'm going to do that same thing. I'm gonna say I cross I less than n. Perfect. Okay, let's try to run it again. Let's try to run it. Perfect. Let's submit it. Perfect. Perfect. So this is the most optimized approach that we have seen, right? So if you see this is square root of n. Okay, it's going till square root of n. If you see this is going from for I equals to 1, for I equals to, sorry, 2, you're going from 4 till n, right? For a value of 3, you're going from 9 to n, right? So for the value of 4, you're going from 16 to n. I mean, let n be anything. 16 to n. So you see how many computations we have reduced, right? In terms of I and j, right? So this is our most optimal approach. Perfect. Thank you so much for watching. I know it's a long video, but this will make you understand what I like how this algorithm is working internally, and so that mm, you do it, even after like 1 month, you do it on your own. Okay. Thank you so much for watching.